Unit 5, Section 12.5, Worked Examples. Match each description to the type of distribution it would have. The number of people per household in the United States. So if we think about this, we're going to have some households with one person, probably more with two and more with three. But when we get into the higher numbers of 8, 9, and 10, we're going to have fewer households. Excuse me. So we would expect this distribution to be a skewed distribution, actually be skewed to the right. The day of the week that a baby is born in the United States. There's no reason to believe one day is going to be higher than another, so we would think this would be a rectangular distribution. The systolic blood pressure of a group of 40 people with high blood pressure and 40 people without normal blood pressure, or with normal, I should say, this should say with normal blood pressure. So we have one group with high blood pressure and one group with normal blood pressure, so this distribution we would expect to be bimodal. The IQ of a group of 1,000 randomly selected U.S. adults. We would expect this distribution to be a normal distribution. Dave drives to work each morning at about the same time. His commute time is normally distributed with a mean of 43 minutes and a standard deviation of 8 minutes. What percent of time will his commute time fall between 35 and 51 minutes? We can use the empirical rule to answer this question. The mean is 43 minutes. How far from the mean is 35 minutes? So if I subtract 35 from 43, I get 8 minutes. And this is the value of one standard deviation. How far is 51 minutes from the mean? 51 minus 43 is equal to 8 minutes, also one standard deviation. And if I look at the empirical rule, what does it tell us? About 68% of the data will fall within one standard deviation of the mean. So 68% of the time, Dave's commute time would fall between 35 and 51 minutes. Same situation. Dave drives to work each morning at about the same time. His commute time is normally distributed with a mean of 43 minutes and a standard deviation of 8 minutes. What percent of the time will his commute last more than 43 minutes? In the normal distribution, the mean, the median, and the mode all fall in the center of the distribution, and the center of the distribution here is at 43 minutes. So 50% of the data will fall above the mean, and 50% of the time, Dave's commute time will last more than 43 minutes. Same situation. Dave drives to work each morning at about the same time. His commute time is normally distributed with a mean of 43 minutes and a standard deviation of 8 minutes. 95% of the time, his commute time will fall between what values? We can use the empirical rule to answer this question. We see from the figure below that 95% of the data will fall within 2 standard deviations of the mean. So we take the mean and we subtract 2 standard deviations, so 43 minus 2 times 8 or 16 gives us 27 minutes, and 43 plus 2 standard deviations, which is 43 plus 16, gives us 59 minutes. So 95% of the time, Dave's commute will be between 27 and 59 minutes. The weights of children age 2 have a mean weight of 25 pounds with a standard deviation of 3 pounds. What is a z-score for a child whose weight is 18 pounds? Remember the formula for z-score, it's shown here. Z-score equals the data value minus the mean divided by the standard deviation. For this problem, the data value is 18, the mean is 25, and the standard deviation is 3. I replace those values in the formula for the z-score, and I get 18 minus 25, which is negative 7, divided by 3, which equals negative 2.33. Notice this z-score is negative. The weight of 18 pounds is below the mean of 25 pounds. Remember that negative z-scores mean those data values are below the mean or less than the mean. The weights of children age 2 have a mean weight of 25 pounds with a standard deviation of 3 pounds. What is a z-score for a child whose weight is 25 pounds? Remember the formula for z-score. Z-score equals data value minus the mean divided by the value of the standard deviation. For this problem, the data value is 18. Sorry, that should be 25. And the mean is 25, and the standard deviation is 3. So the z-score is 25 minus 25 divided by 3, or 0 divided by 3 is 0. Notice this z-score is 0. The z-score for a data value that is equal to the mean is always 0.